Good day everyone and mabuhay. I am Loyd Echalar. With me on this research paper is Dr. Arnel Fajardo, and we're from the Technological Institute of the Philippines, Manila, Philippines. Our research title is CNN's Resnet, YOLO and Faster R-CNN architectures on the disease detection and classification of local agricultural vegetables towards sustainable production. To start with, here are the keywords for our research paper. First is the local agricultural vegetable. The focus of this research project is to develop a technology that improves the production of local vegetable, plants, and crops in rural areas in the Philippines. The second one is diagnosis. Diagnosis, the process of analyzing the problems of the local vegetable, plants, and crops. The third one is the deep neural networks, or the DNN, the algorithm to use in diagnosing local vegetables, plants, and crops. The fourth one is detection and classification, the process of deep neural networks to create significant information from the local vegetable, plants, and crops. And then the last one is the Resnet, or the residual network, or the popular for supporting thousands of convolutions. The YOLO, or the you only look once, popular for speed and accuracy. And then the other one is the Faster R-CNN, used for real-time object detection. These are the architectures of convolutional neural networks, or the CNN, that are used to identify the accuracy of detection and classification in different ways. For the introduction, technology plays an important role in the sustainable production of crops, which is why the emergence of technology and innovative ways must be implemented and embraced by the local farmers and growers, as well as the community. The emergence of technology has led to the development of application software, which plays a crucial role in assisting the individuals with their daily tasks. These software applications employ various methods and techniques to serve specific purposes, and one notable example in image processing, which can be utilized for diagnosing crop issues. As we can see in Table 1B, local vegetable crops have changes in production from the first quarter of 2020 up until the first quarter of 2022 due to different problems. On the next table, we can see that these local vegetable crops have different problems and challenges, such as pests, diseases, nutrient deficiencies, fertilizer, weather condition, and some more. But these challenges have also solutions. But these solutions can be conveniently and easily applied once we use the innovative and emerging technologies. Agriculture contributes approximately 9% to the country's gross domestic product, or the GDP, and serves as a source of livelihood for millions of Filipinos. Based on the data from the PSA, there was a 0.5% growth in the value of agricultural production in the Philippines during the initial quarter of 2021, primarily driven by the significant contribution of crop production. The Department of Agriculture has also been implementing programs to support local farmers, which aims to boost food security and increase agricultural productivity. Detecting diseases and pests in plants and vegetables is crucial in ensuring food security and sustainability. Image processing technology has grown in importance, particularly for the identification and treatment of plant illness and problems. Deep neural networks have demonstrated immense promise across numerous sectors, including agriculture. CNNs and its different architectures as a specific type of deep neural network find widespread application across various computer vision tasks and encompassing segmentation, object recognition, and image classification. As shown in the figure, artificial intelligence, machine learning, and deep learning are the best way to integrate technologies into different sectors, especially in agriculture. In this table, in this diagram, what we are aiming for in the Philippines is to have a sustainable production of crops. But the question is, how we can do that? First, we need to maintain a sustainable agricultural sector through correct and proper ways and resources. Yes, maybe there will be challenges with the resources and access to different information. But with the use of technology and integrating it into the agricultural sector, with the use of different techniques and algorithms such as image processing and more, then we can have now the production of a sustainable and improved crop. To achieve the goal of having sustainable production of local vegetable crops, what we need to integrate is the innovative and emerging technologies to classify and detect problems and provide solutions. But the problem is, what if the local farmers have no access to resources and have difficulties accessing the available information? Then it's time to develop an affordable and user-friendly technology for local farmers. Another question may arise if we develop an affordable and user-friendly technology for local farmers. Then maybe we can encounter difficulties in the detection, classification of crops problem. Then we select better techniques and architecture for the detection and classification in order to solve that problem. The main objectives of this research paper is to integrate CNN's Resnet, YOLO and Faster R-CNN architecture on the disease detection and pest classification of local agricultural vegetable towards sustainable production. Number one specific objective is to develop an image processing application that utilizes deep neural networks, specifically the convolutional neural networks. The second one is to provide assistance to local agricultural farmers in the detection and classification of local vegetables. And then the last one is to identify the significance and accuracy of different CNN architectures such as Resnet, YOLO, and Faster CNN. For the methodology of this research project, to successfully develop the research project, an agile Scrum development lifecycle were used to plan and document the development. Different frameworks and models were used. Literature and related systems reviews were done, and integration of different testing techniques were also done to identify the accuracy, effectiveness, and efficiency of the product. This is the system architecture of our research project. The application is composed of different modules and sub-modules that provides assistance to local farmers. Detection module is composed of two sub-modules, namely disease and pest detection and condition detection. These sub-modules enable users to identify and classify condition, diseases, or pests affecting specific vegetable plants. Additionally, users can obtain information about the type of the disease, pest name, possible causes, and necessary actions to take. App's description and details about numerous pests, diseases, and circumstances that can affect maize harvest are available also to the application. Here is the process of the detection: image acquisition, image processing, image analysis, image recognition, and then the result. For image acquisition, to ensure precise detection, it is necessary to capture a digital photograph of vegetable plants from a particular angle, while considering various factors such as object visibility and clarity, object focus, appropriate distance from the object, clearness of the background, satisfactory lighting, and camera quality. For image pre-processing, there are two ways in which image pre-processing can handle the input data and dataset. The first approach involves extraction of important information from both the original image dataset and the input image. The second method translates the dataset and input image into hexadecimal values before subjecting them to the convolutional neural network. For the image analysis, for successful detection and classification, it is crucial to consider the parameters and thresholds. By utilizing these techniques, the system can improve the accuracy and effectiveness of detection and classification. However, if the loaded dataset is unrecognized or unclear, the results will be inaccurate and inappropriate. For the image recognition, once CNN has analyzed the content of the digital image, it provides a list of potentially detected disorders or diseases and their corresponding confidence values as a percentage. The output is considered valid if the confidence values reaches an 80% similarity threshold. Here are the CNN fully connected multi-layer perception. Multi-layer perception is a model neural network that represents the process of solving problems and creating the best possible solutions. Each of the layers of MLP is very important to produce properties or outputs which can be a basis to solve a particular problem in different fields. The effectiveness of MLP relies on the factors such as the quality of the data, the efficiency of the processes, and the accuracy of the output. A fully connected MLP performs a more complex process than the standard MLP, where all nodes or neurons are connected in adjacent layers. When fully connected MLPs are used, analysis is more complex, efficient, and effective. It will create various significant information and more accurate solutions or outputs. For the results and discussion, these are the prototypes of the mobile application. This includes disease and pest detection module, the information module, and the history module. For the training results, during the CNN training, adjustments to the network's weights and biases are made to minimize the loss function. The accuracy of the network is continuously monitored throughout the training process to ensure the precise classification of data. Accuracy is measured by calculating the ratio of correct prediction to the total number of predictions, indicating how effectively the CNN classifies the input data. It is this discrepancy between the output that was anticipated and the actual outcome or the prediction error. The objective of the training as CNN is to minimize the loss. Therefore, the predicted output should be as near to the real output as is practical. Here is the accuracy of the CNN architecture. As a result, all of them have higher accuracy, which tells that each architecture is designed to serve a different purpose and has its strengths and weaknesses. The research project used three different architecture, which is the Resnet, the YOLO, and the Faster R-CNN. We can notice on this table that Resnet has the higher accuracy rate, which is 94.21%, compared with the YOLO or the You Only Look Once with 87.94%. and the Pastors R-CNN with 82.13% accuracy rate. For the conclusion of the research project, the application helps alert the local growers and local farmers in the management and administration of local vegetable plants and crops, as it classifies and detects the type of diseases and pests and provides some information to solve particular diagnoses. Also, the application provides a user-friendliness environment, efficient and effective modules, and functions for the users. Another conclusion is that deep neural network, particularly the convolutional neural network, has been proven again that provides accuracy in the detection and classification of objects. There are two crucial criteria used to assess a CNN's performance are accuracy and loss. In order to maximize network accuracy while minimizing loss, CNNs are trained. And then the last conclusion, there is no best CNN architecture for the detection of plants and crops diseases and pests, as the Resnet, YOLO and Faster R-CNN provide accurate classification and detection. The selection of a suitable CNN architecture relies on the specific tasks and requirements of the application at hand. It is crucial thoroughly evaluate the strengths and limitations of each architecture before determining the most optimal choice for a given application. And for the recommendation, here are the recommendations for future improvements of the research project and the mobile application. The application has the potential to offer supplementary functionalities such as report module, which will present and analyze comprehensive results from the classification and detection processes. The other one is the application should be mobile phone responsive for easy access of the growers and farmers. And then the last one, an improved CNN may be applied for better accuracy of classification and detection. Other CNN architecture should be used to identify their purpose and significance. And lastly, here are the references used by the researchers to successfully conduct the research and successfully develop the mobile application. Maraming salamat and thank you very much. Mabuhay!